In this session, we consider the limit as x goes to 0 of sine of x over x, and some variations on the same thing. So, in your textbook, there's a proof, there's a geometric argument that the limit as x goes to 0 of sine of x over x is equal to 1. So let's consider that to be given, and then let's consider some more related limits. Okay, so limit as x goes to 0 of sine of 9x over 9x. Let w equal 9x, then that's the limit as w goes to 0 of sine of w over w. That's the same limit that we saw before, so that's also equal to 1. Now let's consider the limit as x goes to 0 of sine of 9x over x. That's almost what we had before, so I can manipulate the form that I have, which is almost like the form that I know how to handle, okay, by multiplying by 1, which doesn't change anything. So I multiply by 9 over 9, and then that gives me the limit as x goes to 0 of sine of 9 times sine 9x over 9x. Okay, I can pull the constant 9 outside of the limit, so that's 9 times the limit as x goes to 0 of sine of 9x over 9x. So the sine of something over something as something goes to 0 is 1, so that's equal to, the entire limit now is equal to 9 times 1 equals 9. Okay, what if we had the limit as x goes to 0 of sine of 9x, sine x over 9x? Well, again, I can multiply by, I could multiply by maybe 1 over 9 in this case, and I would get what I want. What about this one? Limit as x goes to 0 of sine of x squared over x. Well, I'd like to get sine of something over something, so I can multiply by x on the top, x on the bottom, as long as I'm not multiplying by 0 over 0, which I'm not, because x gets arbitrarily close to 0, but is never equal to 0. So, multiply by x over x. So I have sine of x squared over x squared, and I've got x times that. Okay, then the limit of the product is a product of the limits, provided that the individual limits exist. So that's the limit as x goes to 0 of x times the limit as x goes to 0 of sine of x squared over x squared. Okay, which is 0 times 1, which is equal to 0.